let's talk about three common trig identities that pop up like all the time in trig problems and simplifying problems. Actually, they're all kind of instances of one identity that's really easy to remember thinking about the unit circle. So remember the, well actually, unit circle. So let's draw the unit circle. If we go an angle theta here, then we've got a triangle here. This is the unit circle, so the radius is just 1. That's the hypotenuse of the triangle. The point is cos theta sine theta. So this side is sine theta and this side is cos theta. This is a right triangle, so Pythagorean theorem says that sine squared theta plus cos squared theta equals 1 squared, which is still just 1. So this is like the major identity here. It's just the Pythagorean theorem on the unit circle. Now, from that identity, you can get a lot of other identities. Some really obvious ones are that cos squared theta equals 1 minus sine squared theta, and sine squared theta equals 1 minus cos squared theta. You can have things like cos fourth theta equals, well, that's cos squared theta quantity squared, so that's 1 minus sine squared theta squared. So if you expand that out, that's 1 minus 2 sine squared theta plus sine fourth theta. So you've got a ton of relationships there. Now another thing, I'm going to erase these relationships for now. Actually, let's erase that too, just to get some room for the next thing. So this is the first big formula. We can get another kind of big formula by taking that formula, sine squared theta plus cos squared theta equals 1, and divide both sides by sine squared theta. And we can write it in terms of other trig functions. So sine squared theta over sine squared theta just equals to 1 plus cos squared theta over sine squared theta equals 1 over sine squared theta. Well, that's 1 plus this quantity right here is cotangent squared theta, because tangent is sine over cosine. So you flip it around, you get cotangent, and that is equal to cosecant squared theta. So that's another big thing. Now you can probably guess what's going to be the other big formula. We'll take sine squared theta plus cos squared theta equals 1. And now instead of dividing by sine squared, let's divide by cosine squared theta. So now I've got sine squared theta over cosine squared theta plus 1 equals 1 over cos squared theta. Well, this is just tangent squared theta plus 1 equals secant squared theta. So that's another big one. So from these formulas, like we did with that one, you can say cosecant squared theta minus cotangent squared theta equals 1, or secant squared theta minus tangent squared theta equals 1, or you can write cotangent squared theta equals cosecant squared theta minus 1, or tangent squared theta equals secant squared theta minus 1. You've just got a whole bunch of other little things at your disposal just by rearranging these equations. Now, I think the big one to remember is just this one right here, because everything else comes from this equation right here. You can get the other big two equations by just dividing by sine or by cosine. This one you divide by sine, this one you divide by cosine, and then you can just rearrange as you wish. And then the way to remember this one is that it's just Pythagorean theorem on the unit circle. So I know it looks like a lot of different formulas to remember, but really all you have to remember is Pythagorean theorem on the unit circle. That's about it.